Welcome back to CCNA 1. We're going to talk about routing. So, really, routing is when a router or any layer 3 device we can have. Remember, routers, layer 3 switches, or firewalls do routing, the actual process of routing. So, when any of these devices, these layer 3 devices, receives a packet, it's going to, of course, strip off that frame. Remember, we strip off the layer 2 frame, and we're going to read the information in our packet header, our IP header, right? We're going to read the destination. The most important thing is to read the destination IP. Now, keep in mind, if you're using a firewall, it may also read the source IP as well before forwarding the traffic. You may also, if you use an ACL on your router or layer 3 switch, do the same thing. You may specify only certain source IPs can get past this router. And of course, we'll talk about all that in following videos. So first thing, of course, the packet is going to arrive on the interface, right? We're going to de-encapsulate at layer 2. It's going to examine the destination address and forward based on the routing table, and then we will re-encapsulate, right? We still have to have that layer 2 header. So say for example, in this example, PC1 sent something. So this router is going to read it. He's going to read the destination IP address, right? So then he's going to forward it on. And when he forwards it on, he's going to re-encapsulate with his own source MAC address, the destination MAC address of this next router. However, again, the IP information will not change, right? So the source and destination IP address will stay the same from PC1 all the way to PC2. However, the destination and source MAC addresses will change every single time you go through one of these layer 3 devices. So there are 3 types of routes. There are directly connected routes, which means my router, so from this guy's examples, he will have these 2 directly connected networks. Any network that's not directly connected to him, hence directly connected networks, is not going to be a directly connected network. It's going to be a remote network. So any network he has an interface on is going to be a directly connected network. Now, a remote is any network that he doesn't have an interface in. So this could be added manually with a static route. So we could manually type it in as an administrator, or dynamically by using one of these routing protocols, such as OSPF or BGP. And those are dynamically updated too. So right, if a network goes offline or is unavailable, we can remove it automatically from a routing table with no interaction from us as network engineers. It's all done by the routing device. And then we also have default routes, which are a little bit special. They can be manual or they can be dynamic, but they're going to be where we forward everything else, right? If it doesn't match any of the other entries in our routing table, what's kind of our last resort, right? We mentioned that in the last video, the route of last resort. So our static routing is going to be all configured manually. This is great if we have a really, really small network, but when you start to scale the network, 50 routers, 100 routers, 1,000 routers, it really becomes a big chore. So we want to have some kind of dynamic routing. But, for a small network, this is absolutely fine. So manually adjusting these whenever there's a change, there's not many changes in a very small network, it could be fine, right? Good for small and non-redundant networks. Now you can do some really fancy things with static routes if you want to do that for redundancy and some other stuff, but it's usually not recommended. It's usually better to have a dynamic solution. So we may also use it with a routing protocol as well. So maybe we want to use a routing protocol for most of our networks, but we want to have a default route that's separate, or maybe we want to have a specific route that's separate. So most networks are going to have at least a few static routes for specific situations. I know in our case, so we when we connect to other organizations other than ISPs, if we're connected to an ISP, we'll run BGP. However, if we're connected to another organization, another organization we work with or a contractor, we're probably not going to be comfortable sharing our routing table with them. So we're going to provide them with, hey, we want you to put these specific static routes on your network. We're going to put specific static routes on our network for what we want to access from yours. And we can do that way. So internally, we'll be doing dynamic routing, but externally, we might be using some static routes. So dynamic routes are going to be automatic, right? We'll automatically discover remote networks. We'll automatically update our information. We will automatically choose the best path, and those determinations are done by the routing protocol. Now, there are different routing protocols, and they handle things differently. We'll talk about OSPF a lot in the following courses, and we'll get into the details of that. But just know for now, there's different routing protocols that are going to choose different metrics to choose the best path. And maybe if there's something changes, we need to find a new best path. So we can also share static routes and routes from other routing protocols. So we call this route injection. So we could inject routes, such as static routes, into a dynamic routing protocol. So show IP route is the command that you should become very familiar with when we talk about routing. And really, this is going to be, first of all, we have the legend, right? It's going to tell us, hey, S is a static route, C is a connected route. Let me clear the screen here. C is a connected route, S is a static route. R, RIP, that's a protocol, a routing protocol. B, BGP, right? We talked about that. EIGRP, another routing protocol, etc., etc. So if you forget what any of these say in the real world, then you can reference this legend. However, I will say, for test purposes, don't rely on this legend being there. It might not be there on the test. L is a locally connected interface. That's another one to know. So you'll see these are usually in pairs, C and L. So we connected, which is the whole network, and then there'll be L, which is link local, which is just that one interface. So when you see a /32, that means only that one singular IP address is going to be used there. And this is something they added in a recent version of iOS. I think it was 15.1 they added it. And I'm not entirely sure why they added it, but they did. So there it is. Of course, static routes, right? We add those manually. OSPF, for example, would be O. Very easy to remember there. D is EIGRP. And that's because E was used for something else. I don't think it's listed here anymore. E was used for something else, and so they couldn't use E, but so they used D. So we'll see in this command over here, C and L routes connected and link local, remote routes, OSPF. They don't have EIGRP, but EIGRP would be D, etc. And default routes would be S star. You'll see that, right? We have our gateway of last resort, or our route of last resort. Right, and with that, again, with the summary, look at these questions, look at these statements, see if they make sense. Hey, could I explain this concept? Could I explain to someone else? And if you can't, go back, review, and I'm more than happy to answer any questions if you have any. With that, thank you for joining me for Module 8. And I'll be back in just a few moments and do Module 9.